Let's look at the slide of this purple onion. It's being exposed to a salt solution. In this purple onion sample, what you're seeing before your eyes is osmosis, a type of passive transport where water moves through a semi-permeable membrane from an area of high concentration to an area of low concentration. Let's consider these beakers. We have the beaker to the left, we have a beaker in the middle, and we have a beaker on the right. Each beaker has a different solution in it, and it's obvious because it has a different effect on the cell. If we look at the middle beaker, the beaker with the hypertonic solution, you can see that it causes that cell to shrink, just like you saw with the purple onion cells. When you have a hypertonic solution, you have a solution where there is less water in the solution than there is in the cell. Consider yourself stranded in the middle of the ocean. You're surrounded by salt water. Are you going to drink that salt water to quench your thirst? You wouldn't dream of it. And the reason you wouldn't dream of it is because that ocean water is going to be hypertonic to your cells. It is going to pull water out of your cells because it has a much higher solute concentration and lower water concentration than your cells, which means water moves from your cells into the solution because it moves from high concentration to low concentration in a hypertonic solution. You also want to consider a time where you might gargle with salt water. Your throat, when it becomes irritated and swollen, your cells swell up. When you gargle a saltwater solution, you are relieving the swelling by using a hypertonic solution to pull water out of those cells. Now in the left beaker, you have a different situation. You have a cell that is in a hypotonic solution. For example, distilled water is considered to be 100% pure water, which means it's 100% solvent, and there are 0% solutes. Solutes are things like salt, sugar, and other such things that are dissolved in solutions. In the solution in the left beaker, with distilled water being at 100%, the cell in this beaker has 90%, which means that there's more water in the solution, less solutes. Therefore, water moves from the solution to inside of the cell, causing that cell to swell and take on water. When you are looking at an isotonic solution, you're looking at the beaker to the far right. Here, the cell is balanced because the solution has the same amount of water percentage as the cell. And when you have that, there's no net loss or gain. It is said to be at an equilibrium. So again, here you have a hypotonic solution in beaker A, a hypertonic solution in beaker B, and an isotonic solution in beaker C. These are all examples of osmosis or passive transport, where that water is going to want to move from high concentration to low concentration. It wants to move with the concentration gradient.